So, hello everyone. For today, we are going to talk about introduction to cluster analysis. So, what is cluster analysis? Clustering is the process of making a group of abstract objects into classes of similar objects. So, ang clustering daw is a process kung saan ginugroup niya into classes yung may magkakaparehong mga objects. Next. Next, we have applications of cluster analysis. Clustering analysis is broadly used in many applications, such as market research, pattern recognition, data analysis, and image processing. Clustering can also help marketers discover distinct groups in their customer base, and they can characterize their customer groups based on the purchasing patterns. So, ang cluster analysis daw is mainly ginagamit siya in market research, pag-trace or pag-track ng patterns or pag-recognize. Then, marketers are able to characterize what and who their customers are based lang sa kanilang madalas na records of their purchase or based on the purchasing patterns na sinasabi. And in the field of biology, it can be used to derive plant and animal taxonomies, categorize genes with similar functionalities, and gain insight into structures inherent in population. Like in the field of biology daw, it helps them out to classify and categorize yung mga different classification ng plant and animal
Persian King.
based sa mga magkakaparehong functionalities.
Maliit na Persian.
Clustering also helps in the identification of areas of similar land use in an Earth observation database. It also helps in the identification of groups of houses in a city according to house type, value, and geographic location. Clustering also helps in classifying documents on the web for information discovery, also used in outlier detection applications such as detection of credit card fraud. As a data mining function, cluster analysis serves as a tool to gain insight into the distribution of data to observe characteristics of each cluster. What is clustering methods? Requirements of clustering in data mining includes scalability, ability to deal with different kinds of attributes, discovery of clusters with attribute shape, high dimensionality, ability to deal with noisy data, interpretability. Then clustering methods includes partitioning method, hierarchical method, density-based method, grid-based method, model-based method, and constraint-based method. So, partitioning method. It classifies the information into multiple groups based on the characteristics and similarity of the data. It's the data analysis to specify the number of clusters that has to be generated for the clustering method. Partitioning method. Suppose we are given a database of n objects and the partitioning method constructs k partition of data. Each partition will represent a cluster in k. It means that it will classify the data into k groups, which satisfy the following requirements. Each group contains at least one object. Each object must belong to exactly one group. And remember, for a given number of partitions, say k, the partitioning method will create an initial partitioning. Then, it uses the iterative relocation technique to improve the partitioning by moving objects from one group to another.
Is hierarchical methods. So hierarchical methods create a hierarchical decomposition of the given set of data objects. You can classify hierarchical methods on the basis of how the hierarchical decomposition is formed. So there are approach in hierarchical methods. Agglomerative approach. This approach is also known as the bottom-up approach. In this, we start with each object forming a separate group. It is on merging the objects or groups that are close to one another. It also keeps on doing so until all of the groups are merged into one or until the termination condition holds. Divisive approach. This approach is also known as the top-down approach. In this, we start with all of the objects in the same cluster. In the continuous iteration, a cluster is split up into small clusters. It is down until each object in one cluster or termination condition holds. This method is once a merging or splitting is done. It can never be undone. Approaches to improve quality of hierarchical clustering. So it performs careful analysis of objects linkage at each hierarchical partition. It also integrates hierarchical agglomeration, first using a hierarchical agglomerative algorithm to group objects into microclusters and then perform macro clustering on the microclusters. Next is the density-based method. This method is based on the notion of density. The basic idea is to continue growing the given cluster as long as the density in the neighborhood is some threshold for each data point within a given frame at least a minimum number of points. Next is the grid-based method. In this, the objects together form a grid. The object space is quantized into infinite number of cells that form a grid cluster. Evaluation of clustering. Three important factors by which clustering can be evaluated. The cluster tendency, number of clusters, clustering quality.
Clustering tendency. Making sure that data set we are working has clustering tendency and does not contain uniformly distributed points is very important. Without clustering tendency, clusters identified by any state-of-the-art clustering algorithms may be irrelevant. Non-uniform distribution of points in data set becomes important in clustering. To solve this, Hopkins test, a statistical test for spatial randomness of a variable, can be used to measure the probability of data points generated by uniform data distribution. Null hypothesis, or HO. Data points are generated by uniform distribution, implying no meaningful clusters. Alternate hypothesis, or HA. Data points are generated by random data points, presence of clusters. Number of optimal clusters, K. Finding the optimal number of clusters lead to a granularity in clustering. Finding right number of clusters depend upon A. Distribution shape, B. Scale in the dataset, C. Clustering resolution required by user. Two major approaches to find optimal number of clusters. Domain knowledge. Domain knowledge might give some prior knowledge on finding number of clusters. For example, in case of clustering iris dataset, if we have the prior knowledge of species Certosa virginica versicolor, then k equals 3. Domain knowledge driven k value gives more relevant insights. Data driven approach. If the domain knowledge is not available, mathematical methods help in finding out right number of clusters. Empirical method, elbow method, statistical approach. Clustering quality. Once clustering is done, how well the clustering has performed can be quantified by a number of metrics. Ideal clustering is characterized by minimal intra-cluster distance and maximal inter-cluster distance. Types of measures to assess the clustering performance. Extrinsic measures. Required ground truth labels. Examples are adjusted rand index, Volkel-Mallows scores, mutual information based scores, homogeneity, completeness, and V measure. Intrinsic measures does not require ground truth labels. Some of the clustering performance measures are silhouette coefficient, Kalinski-Harabas index, Davis-Boolean index, etc. Advanced cluster analysis. Cluster analysis is the task of segregating a set of objects with similar characteristics and assign them into different clusters. In this spot, we will look towards some advanced topics of cluster analysis, specifically the four major perspectives of advanced clusters analysis: probabilistic model based clustering, clustering high dimensional data, clustering graph and network data, clustering with constraints.